Yo, what up, everyone? Welcome back to my stream. Welcome back to my channels. Subscribe. I'm on YouTube, Rumble, Twitch, and Kick. Alright, let's continue fucking learning Linux on Boot.Dev. Alright, let's see. Do today's lesson expires in 1 hour. Let's check the leaderboards first. Top daily learner. I am not even part of it. You are in the Starlight Thunderbird League. League expires in 12 days. Alright, position 5 of league members. Okay. Top daily learners. 10,000. Yep, that's what happens when I stop to play video games. Alright. Back in developer path, we are on file system still. We're going to finish that off and then start on permissions. Probably finish. I'm not even going to say. We may or may not finish it. Oh, wait, what? I clicked on it. I ain't trying to reset it. What button did I press? Oh, this one. That's why. Alright, we are on this. Okay, home. Let me put the volume down to 60. Yeah, that's good enough right there. Okie dokie. So, home. In a Unix-like operating system, a user's home directory is their directory where their personal files. Hold up, one moment. Alright, mic is on, desktop audio is off. Alright, good. Because I'm listening to Pandora, I don't want to get copyrighted. Alright, in a Unix-like operating system, a user's home directory is the directory where their personal files are stored. It is also the directory that a user starts in when logging into their system. I recommend doing all of your development work in your home directory. For example, I like to create a workspace directory in my home directory, and all my programming projects live in subdirectories there. Danger. Your home directory is where you want to spend most of your time. Many of the other directories on your machines are critical to the operating system or other programs. Be careful when working in other directories like bin, etc, and var, etc. You can mess up your system if you're not careful. The whatever that shit, that's not an asterisk. Squiggly line or squiggly line alias. I don't know. My home directory on Mac is located at users /. The squiggly character is an alias for your home directory, so when I want to go home, I don't have to type out cd fucking users /. I can just type cd. Alright. Where is the file path workspace names.csv referred to? Workspace file in a names.csv directory in the home directory. No? Okay, I should have read all of them. A names.csv file in a workspace directory in the root directory. A names.csv file in a workspace directory in the home directory. Home, this is root. This is a names.csv file in the workspace directory in the current directory. Names.csv file in a workspace directory in the current directory. So I put this one. It's this one. Alright. Oh yeah, let me change the view for my screen capture so you can see everything on my PC. This one. Alright, let me move this shit to the right, minimize. Let's open this up, put it towards the right, and let's make this bigger so you guys could see. Alright, you might be used to a nice graphical interface that allows you to search for text in files, usually the Control plus the F or Command F. But what about when you're working in a terminal? Let me drink some beer. As it turns out, once you've used it, searching for the text in files in a CLI can be much faster than using a GUI. Alright? The grep command. The grep command allows you to search for text in files. It has a ton of capability and will only be scratching the surface of its true power. Basic usage. The most basic use for grep is to search for a string in a file. For example, if we wanted to search for the word hello in the file words.txt, we could run grep hello in the words.txt file. Okay. This will print out every line in words.txt that contains the word hello. It's a case-sensitive search, so it will only match hello, not capital H hello or all caps hello. Assignment. Applications often write their logs to files on disks. These logs can contain useful information about what the application is doing and can also be used to debug problems. As a security auditor, you need to dig through these logs to find any evidence of suspicious activity. Use the grep command to find any lines within the critical all caps in with the text critical all caps in the World Bank private logs 2024-01-10.log file. Paste the output of your grep command into the input field and submit it. Tip. Alright, the tab key is your friend. If you start typing the name of a file or directory and then press tab, your shell will try to autocomplete the name for you. If there are multiple possible completions, it will show you a list of them. I rarely type out full file names. I type the first few characters and then press tab. Okay. So I'm gonna grab fucking oh shit. Oops. Let's restart. Control L. Let's grab all caps critical critical oh wait, I have to put these, I think. And then words.txt. Okay, which file? So let's see, World Bank. World Bank /private. Let me see if tab will private logs /2024 2024 let me press tab 0101 0 comes out .log 2024-01 10.log file. Alright. And then let's see. Boots is loose in the server room. Server is on fire. Please evacuate. Someone remove the the root directory. Data files are corrupt. Okay. So let's copy all of this. Copy. Paste. Submit. It's all they wanted from us? Alright. Is this different? Yeah, it's different. Alright, grep multiple files. You can also search multiple files at once. For example, if we wanted to search for the word hello.txt and hello2.txt, we could run. Alright, so we're searching for hello in any of these two texts. Okay. Recursive search. You can also search an entire directory, including all subdirectories. For example, to search for the word hello in the current directory and all subdirectories, grep -r, so flag r, grep /r, hello. The dot is a special alias for the current directory. Didn't even notice that. Assignment. Use the grep command to find all the lines with the text critical all caps in the World Bank private logs directory. Alright, so let's see. Let's go to pwd, see where we're at. So first we have to cd cd to World Bank. Shit. World Bank fucking private. What the fuck? PR tab private logs. Alright, so now I'm in logs. Now I'm gonna grep critical. Let's see. The dash. Let me fucking delete all of this. Put a dot there. Go over here. Put -r. And then space it. Search. Alright, so World Bank Monitoring Systems offline boots is out of salmon again. Someone removed the French. Remove the fucking root directory. Security scan is being maliciously manipulated. No one paid Dennis Nedry for his work. T-Rex there's more to it. Let me full screen it. T-Rex released. Kernel panic. Not syncing. VFS unable to mount root FS on unknown block 00. Boots is loose in the server room. Server is on fire. Please evacuate. Someone remove the root directory. Database files are corrupt. Power to the main data center has been lost attempting to reconnect. Alright. So we're going to copy all of this. There we go. Alright. Here's the assignment. It says paste the output to the grep command into the input and submit it. Let me paste everything there. Just the grep command, right? So I don't need that. There we go. Alright, find the command. Find. The find command is a powerful tool for finding files and directories by name, not by their contents. Find a file by name. Let's say you're looking for a file named hello.txt somewhere in your home directory. You can use the find command to search for exactly that title. Find some directory dash name hello dot text. Okay. Okay, so this is the name of the directory. Dash name hello dot text is the file name. Alright. Pattern search. The find command can also search for files that match pattern. For example, if you wanted to find all the files that end in the .txt, you could run find some directory dash name. So just double quote asterisk dot text. Oh, put all of this in quotes. Okay, asterisk dot text, and then double quote it. Alright, the asterisk character is a wildcard that matches anything. If you're trying to find file names that contain the special word, you can use the asterisk character to match the rest of the file name. Alright, find all file names that contain the word Chad. Find some directory name Chad. Okay, so oh wait, double. They both have to be in asterisks? No. This is for a pattern search. Why does this one get 2 asterisks and this one doesn't? Alright, you've been tipped off that fraudulent activity seems to happen often with joint accounts. Joint means accounts that have more than one owner. CD into World Bank and use the find command to search the public products directory for all files that contain the word joint in their name. Paste your output and find command into the input field and submit it. Alright. So how do I go all the way home again? CD in the squiggly makes me go home. Okay. Yeah, that's the last one. Alright, let's clear this bitch. Well, actually, I only have to go back twice, so CD freaking 1 2 1 2. Too many arguments. CD Alright. CD one more time. I'm in World Bank now. Alright. Let me clear this bitch out. Now I'm going to what again? Alright, CD to the World Bank and use find command to search public products directory. Alright. For joint. Okay. It says for all files that contain the word joint in their name. Pattern search, find a file name. Alright. Find inside the public products public / products okay public products directory for all files that contain the word uh, dash name. Nope. Nope. Where's the asterisk at? What's on 8? Let's see. We're searching for joint. Nope. Joint. Asterisk is on 8, and then finish it off with that. Alright. So joint rewards, Plux, joint savings, joint checkings, joint loan shark. Alright. Let me copy all of this. Go here and paste it. Submit. And we're good. Next. Alright, we're now on chapter 3, permissions, and this has 6 lessons. Terminals and shells, file systems, permissions, programs, input and output, packages. Alright. Alright, users use Unix-like systems. You guys can still hear me, right? Everything should be good. Yep. Alright, users, Unix-like systems like the one you're using support multiple users. Each user has their own home directory, their own files, and their own permissions. If you're like most people these days, you're the only user on your machine. It used to be more common for multiple people to share a single computer, or for multiple people to do their work on the same computer over a network. Not anymore. Sudo, the sudo keyword lets you run a command as a super user. It's short for super user do. Alright, to use it, you'll need a password with the super user privileges, which you should already have if you're the only user on your machine. Some people are pedantic and pronounce sudo as sudo. Others are correct and pronounce it sudo. Haha, you guys are wrong. Sudos. Sudo grants unrestricted access and can risk system damage. If you don't know what you're doing, all commands in this course are safe, but other commands should be reviewed before running excuse me, with sudo. Assignment. Run the who am I command to see which user you're logged in as. Alright, let me clear this out. Alright, who okay, what the fuck? Let me fucking who am I? Or who I am, who am I? Alright. Then sudo who am I? And then it asked me for a fucking password. Okay, root. Alright. Check. Check. Alright. On some Linux systems, your user might not be configured for sudo access by default. If sudo who I am fails with the permission or authentication error, your account may not have super user privileges. 3. You'll be prompted for your password. Enter it. Alright. Copy and paste the output of the last command into the input box and submit your answer. Alright, so the last command. There we go. Alright. Next, permissions. Oh, we're going to be watching a video. Let me pause this. Let me go to here. Unmute you guys so you guys can hear the audio. And, alright. So, permissions. In a Unix-like operating system, permissions control who can do what to which files and directories. The permissions of an individual file or directory are visually represented as a 10-character string. Click. Alright. Full screen this bitch.
In a Unix-based operating system like macOS or Linux, all files and directories have a set of permissions associated with them. Now, there are two ways that we break down those permissions. The first is who has the permission. The second is what permission do they have. Now, in regard to the what, any user accessing a file or a directory may or may not have access to read it, write to it, or execute it. Now, all of those permissions, both the who and the what, are represented by a 10-character string. The first character is always either a D or a dash. If it's a D, all that means is this is a directory. If it's a dash, it just means this is a file. The next three characters, R, W, X, represent the three permissions that we talked about: read, write, and execute. And the who that they apply to is the owner of the file or directory. The owner is usually just the user that created it, but it can be changed manually. Now, this RWX section can have several different states. Each permission can either be granted, in which case the letter is present, or it can be a dash, in which case the permission is not granted. So, for example, RWX means that the owner can read, write, and execute, while R-X means that they can only read and execute, but not write. And R dash dash means that they can only read. Finally, this set of RWX permissions is just repeated twice more. The next set applies to the group instead of the owner, and the last set applies to everyone else. So to break down a full 10-character string, let's take the example of D RWX R dash X R dash dash. The D means that this is a directory. The RWX means that the owner can read, write, and execute. The R-X means the group can read and execute. And the R-, just means that everyone else can only read this directory.
All right. Pretty informative. All right. Let me go back to muting you. I need to listen to my oldies. Alright. Let's break down each character. The first one just tells you whether you're looking at the file directory, just like he said. Regular files is a dash. Alright, directory is D. The next 9 characters are broken up into 3 sets of RWX and represent the permissions themselves for the owner, group, and others in order. Each group of 3 represents permissions for reading, writing, and executing in order. So, for example, RWX, they have all permissions. RW- read and write only, but not execute. Read-X, read and execute, but cannot write. The first 3 characters are owner permissions. The owner is usually just the user who created the file or directory, but it can be manually changed. The next 3 characters are group permissions. Unix-like systems support groups of users in and each file or directory is assigned to exactly one owning group. Anyone who is not the owner and not a member of the group falls under others. To be honest, unless you're a system admin, you won't often worry about groups. The last 3 characters are other permissions. This is everyone else. In my experience, when you're doing programming work on your own local machine, you mostly just care about the owner permissions because that's usually you. Here are some full examples. Alright, so a file where everyone can do everything is this right here. A file where everyone can read and execute, but only the owner can write, here. A directory where everyone can read ls, the contents, and execute cd into it, but only the owner can write modify the contents, is this one. Directory where only the owner can read, write, and execute. So, there we go. Which permissions allow everyone to read? Alright, so the R's. So I'm looking for 3 R's. This one is the only one. Alright. But more videos. Alright, unmute so you guys can hear. Permissions in a Unix-like operating system. This is the same shit, isn't it? Yep. Alright, which permissions allow the owner to execute? Owner to execute. Permissions. Which permissions allow the owner to execute? This one. Because it's the only one in the, like, the first RWX right here. Skip this one. RWX. This is the only one that has an X on it. Alright. Looks like I didn't have to unmute and mute my music. Alright. Let me just double check. Alright, good. Changing permissions. The chmod command allows you to change permissions of a file or directory. It's short for change mode. I wish it was called change permissions, but alas. Assignments. As part of your security audit, you need to know who has access to the files in the private directory. The ls command has a -l option, lowercase l, that will print out the permissions of each file and directory in long format. Alright, list the files in the World Bank private directory along with their permissions using ls-l so you can see the current state of affairs. Alright, so let's do that. What's up, girly? What's up, Kai? What's up, Kai? What's up, girl? What's up? Huh? Did you eat your num-nums? Eat your num-nums. And then later on, what time is it? 11:20? 11:21. You eat your num-nums and I'll take you out for potties, alright? For walkies and potties. Alright? Pa. Alright, get out of here. Get out of here. Alright, what was I? List the files. Okay, so first I need to see where we're at. Alright, World Bank. So let me go to see fucking private. Alright. List the files in the World Bank private directory along with their permissions using ls. List the permissions so you can see the current state of affairs. Okay. Second, change the permissions of the private directory and all its contents so that the owner can read it, write it, and execute. The group can do nothing and the others can do nothing. So chmod dash capital R U equals RWX comma G is for groups equals comma O is others equals and then directory. What? Okay, cannot access directory, no such file or Workbench private directory. List all the files in the directory along with their permissions. Okay. Chmod space dash R user rwx comma g equals comma o equals. Alright, so let me actually finish reading. In the command above, U means user, G means group, O means others. RWX is rewrite execute. The G equals and O mean the set a group. Set the group and other permissions to nothing. The dash R means recursively, which means do this to all the contents of the directory as well. Be sure to replace directory with a path to the private directory. Remember, dot is a special alias for the current directory. Oops. I wasn't actually supposed to put directory. I was supposed to put the directory name where it says directory. And let's just put a dot because I'm currently in the correct one. Alright. Once you change the permissions, run ls dash l. Alright. Alright, so only the user can make changes here. Alright, so paste only the 10 character permission string of the updated private directory itself, not its contents. A 10-digit, the 10 character permission string of the updated private directory itself, not its contents, into the input field and submit your answer. Tip: if you're using WSL and Chmod, it's not updating the permissions. Your world-bank directory may be on the Windows file system instead of inside WSL. Try moving world-bank into your Linux home directory first. If you need to keep working on the Windows file system, you can adjust your WSL.conf file to allow editing permissions. Alright, so where is it? Right here. So it's just these 10 right here. Copy. And then paste this shit right. Alright. Follow the directions correctly. Alright. I got 1, 2, 3, 4. 4 more left. Let's see how I'm doing on time. Try to keep this within an hour. Alright, we're making good time. 40 minutes in. We'll finish oh, there's 9. Okay, we'll try to finish this whole chapter and then stop sharing. Executables. What happened to my fucking music? Commercials. There we go. Executables. You're familiar with the idea of reading and writing data into files, but what about executing them? Executable files are just files where data is stored inside. Where the data stored inside is a program that you can run on your computer. Files with a .sh extension are shell scripts. They're just text files that contain shell commands. You can run a file in your shell by typing its file path. My dir my directory program.sh. Interestingly, if the program is in the current directory in this example, the my directory, you just put a dot in there, dot / to run it. Alright, as far as file paths go, dot / program.sh and program.sh are the same. The dot is an alias for the current directory. We need the prefix when running executables so that the shell knows we're trying to run a file from a file path, not an install command like ls, make directory, chmod, etc. Assignment. There seems to be a suspicious script in the World Bank private bin directory called genids.sh. It looks like it generates some type of identifier first. First, let's remove our ability to run it. Just to see what happens, the chmod command has a convenient -x flag that will simply remove the executable permission from the file. So, 1. Run the following commands in the World Bank private bin chmod -x genids.sh. Alright, let's clear this bitch. Clear, and then let's see where we're at. We're in private. Now we need to go inside bin. Bin, not Ben. Alright, we're in the bin. Now we gotta chmod. Wait, what the fuck? This shouldn't be in my Cholo radio. What is this? Paper planes? Alright. Where's it?